It's a very, very interesting ecosystem that you've developed because it feeds on itself, and there are multiple industries that could be approached. Your first implementation is the localized on a per factory model, which is very, very tangible because you don't have to destroy the rest of the infrastructure. When you went through the cost analysis, what would be the trade-offs? What would be the selling point? What would be motivating a given industry, a given company to do such?
So algae overall is a very interesting subject for a lot of countries around the world. Investments can come from anywhere. It's happened a lot in other countries such as Chile, Vietnam, stuff like that. So foreign investment could also be a possibility. There's international fairs for algal growth, where researchers around the world come together, demonstrate different possibilities. In terms of spreading towards the rest of the country, we never intended algae to be the complete one-size-fits-all solution to wastewater treatment or to animal feedstock. It's just taking advantage to what is there, using what we consider waste currently, and turning it into products either as compost, feed, or any other of the future implications. Not all the plants have to follow the same model. You know, if they want to expand to another plant and not take into consideration flue gas, they can just stick to an open pond. And these aren't the only two options. There's plenty of other designs. In one of the previous slides I had for other photobioreactor options, closed photobioreactors, instead of having hard acrylic tubes, they had sacks that are a lot more portable because you can pretty much empty out the water and roll it away. Obviously, it's all pros and cons, though, in terms of durability.
What I liked very much was your ability to do computer simulation and actually define what the different variables would be to the application itself. That shows a level of depth of understanding of what the parameters are and would go a long ways to your selling of the approach. So, congratulations, extremely well.
Yeah, what we've noticed about computer simulations is that it's pretty much I don't know if Arturo wants to talk about it, but it's mainly the step between having a small scale system and expanding into a much larger scale. There's pros and cons depending on how Cuba would handle such a system, but with testing on a pilot scale, it can definitely help. I don't know if you want to add.
Yeah, the idea of having that type of control can be very beneficial. I thought of it in terms of the workforce, and in terms of the amount of, or how we go about paying or providing the necessary workforce to maintain the system throughout an extended period of time. By implementing the electronic components, you can diminish the amount of workforce that you need per overall in the infrastructure.
In your specific project, do you calculated the amount of algae product, meal or powder or concentrate, that is produced by that particular plant, and the value of that, and also as a compost, what is the value from the fertilizer standpoint, NPK, of that compost, and what is the amount of the compost produced by that particular unit?
Okay, so it's a difficult calculation to make since it all depends on a variety of factors and variables in terms of growth in Cuba and the efficiency of the system. But we did consider some rough estimates in terms of comparisons to traditional feedstocks, such as soybean meal. And to make it a point, you don't only feed pure soybean meal. It's mixed in with other agricultural byproducts as well. In Cuba, they tend to use bagasse sometimes and stuff like that to create a well-balanced nutrient. And the calculations we ran were the standards for nitrogen and phosphorus that specifically cattle require, and how much is produced on typical existing systems on a large scale in efficiency per meter squared of algae grown in ponds and in closed photobioreactors. And using those numbers in terms of turning it into the scale of our system, our system was at the level of, I think it was like 18 meters squared of exposed algae growth, and using that and the nitrogen and phosphorus levels required by cows, we were able to figure out approximately like 45 cows is what we would be feeding in terms of pure dependence on algae for nitrogen and phosphorus. And that's to feed the cows daily for an entire year, assuming a growth rate of 270 days of availability during, taking into consideration maintenance, closures, not being able to grow year round. That's also assuming that it's pure algae feed and not mixed with bagasse. That'd be hard to calculate as well. But our estimate is approximately 45 cows. It could be higher, it could be slightly lower.
And to answer about the compost, we didn't really analyze compost very much because compost was like a worst case scenario, as in like whatever we harvested wasn't good enough or safe enough for the livestock to eat. So it'd just be like a byproduct. We'd be able to give it to aquaponicos or any other like farm or just areas that needed the fertilizer. It wasn't meant to sell it or to give it a specific value.
Overall, composting between the solar radiation and decomposition leads to some further treatment in that sense of any pathogens or any other types of contaminants. I hope I answered your question.
Can you tell me something about as to why Cuba had success or failure in the use of algae?
So one of the things we were noticing was they did a lot of things in terms of Cuba wasn't focused on animal feedstock or on compost or on biogas. They were focused specifically on deriving medical raw materials out of algae. That's what they were most interested in to develop their pharmaceuticals. Stuff like glycerol, and the list is very long for algae like spirulina and chlorella in terms of different raw materials you can use for medical supplies, for medical field. And they focused on using artificial fertilizers to increase yields, pretty much almost at a lab scale in terms of how well controlled it is. They didn't grow anything on, wastewater or flue gas or anything like that, and that doesn't take into consideration the fertilizer cost. Our solution would have pretty much free feedstock for the algae, while they were pretty much growing it as another plant, as any other agricultural plant, and in a very controlled scale. Also, the other thing was what I mentioned, they're very permanent structures. All of them are concrete. Sometimes they would build it, do all the research, and then just abandon the site. Move on. Or it was very, not very well situated as well. Thank you.